Okay, just verifying that the recording has started. So in this problem number 7, we are told to flatten the linked list to a single linked list. What we're given is a linked list where, yes, we have next pointers, but each node in this upper linked list may or may not have bottom pointers. So 1 points to 4 and 5 points to 7. What we're told to return is 1 to 4 to 5 to 7 to 8 to null, where the bottom pointers indicate the next element in the list. We're not building left to right, we're building top to bottom. So what I'm going to do is create a merge function and a flatten function. The merge function is going to be essentially the merge function will take care of, let's say there were only 2 nodes in this list, right? 1 and 5. The merge function would merge these two, 1, 4, 5, and 7 into one list. And flatten is going to work to direct our progress from right to left. So first, what will happen in my solution is 5, 7, and 8 will be merged into one list, and then 1 and 4 will be merged with that new list. So let me get started and with the merge function definition. So we're going to be returning a node from this function, actually from both. Merge. And in will go 2 nodes, as I discussed, node A and node B. This merge function is used to merge, let's say, these 2 linked lists or these 2 linked lists, any 2 linked lists. So I'll handle the base cases here. If A is null, right, the head of this node is null, then we're just going to return B. And likewise, if B is null, then we will return A. Basically, if one of these is null, we don't have to do any merging. I'll create a node called result, and I'll check on the data values stored in both A and B. So if the data in A has a lower value than the data in B, then we'll assign this result pointer to A. That'll hold the head of our new list, and then the bottom element of our new list becomes merge, if I can spell, merge of A dot bottom and B. So let's think about what that means. If the data in A is less than the data in B, then A gets put at the head of our new linked list. So let's say we're merging 5 and 7 with 8, right? 5 gets put at the head, and then what we're doing is we're going to then compare A dot bottom. So we're going to compare 7 and not N and 8. So if the value of the data of A is not less than the value of the data of B, then B is the new head of this temporary linked list, and B dot bottom is going to get the value of merge of A and B dot bottom. Oh, excuse me. I had a sushi burrito last night. That was a questionable decision. Okay. And then result dot next. Once we're done recursing on our temporary head nodes A and B, we'll assign result.next to null. And we will return results. Okay. Now I will create the flatten function. We'll also return a node from here. Not flatter, flatten. And we will take a node as an input. Okay. Handling the base case. If root, so if what we pass in is null, or root.next is null, similar to these base cases, then we're done flattening and merging, and we can just return root. Okay, so now we'll recurse on the next pointer of the list. So root.next becomes flatten of root.next. Essentially, what we're doing here is calling flatten on each set of linked lists. Calling flatten on each individual linked list. So the linked list that 1 points to, below it, linked list that 5 points to, linked list that 8 points to. Okay, so then after those calls have been sent out, root becomes merge of root and root.next, and then we will return root. Okay. I will discuss the space complexity and time complexity. Time complexity, we're only traversing over each node once, so our time complexity is going to be big O of n, where n is the total number of nodes in this entire amalgamation of linked lists, and space complexity is constant. We're not using any auxiliary space here. Okay, so big picture idea of what's happening. So first, these flatten calls get sent out until we reach the end here, and then merge of 1 second. Okay, merge of the 5, 7 list and 8 is up, so let's take care of that. We enter into merge. If A is null, return B. If B is null, return A. No, we don't have to do that. Node results. Okay. If A.data is less than B.data, that's true. 5 is now, let me do this. I will show what A and B are. So A.data is less than B.data. Yes, it is. Result is A. All right. Result is now 5. Result.bottom is merge between A.bottom and B. So now we're doing merge of 7 and 8. So now A is going to come in here as 7. So now we're comparing 7 and 8. If 7 is less than 8, yes it is. Result is A. Result.bottom is the merge of those two. Okay, so now 8 is getting assigned down here. All right. And then result.next is null, right? Return result. So 8.next is null. So then we come to the next flatten, which we need to flatten 1's linked list and 5's linked list. So we essentially performed the same process on the merge has the same behavior. So this becomes 5 becomes 7, 7, and then eight, and then we are returning root, which is 1, which is exactly what we want to be returning.